Welcome to my basement. I'm going to show you a video. I know this is probably a review from the video you may have hopefully have watched by now, but I want to go over the 5 types of particle decay. And the first type is called alpha decay. And alpha is this kind of funny looking symbol. And essentially an alpha particle is a helium nucleus. And so if something undergoes alpha decay, essentially it's losing a helium nucleus. So I'm just going to make up an element. Let's just say we're looking at chromium. Of course, chromium is 24. And let's say we're looking up 54 as an isotope of chromium. And so let's say that it goes through an alpha decay. Then we end up with the helium nucleus. And what you have to do then is subtract the 54 minus 4. And so then you would obviously get 50, and 24 minus 2 is 22. And you look on your periodic table and you see that that is titanium. So an alpha display or an alpha particle breakdown then would give us the element titanium if you start with chromium. Again, just looking at the mathematics, it all adds up. Well, the second is beta. And beta sometimes you see as something like that. A beta decay is when we lose a beta particle. A beta particle is essentially an electron. What I'm showing here is it has 0 mass and has a -1, obviously, for its charge. So if something goes through a beta decay, it is basically, well, let's just show you here. Let's just pick on chromium again. And let's say then that it undergoes a beta decay. Then what happens is it is losing an electron. So if you can imagine, again, this is coming from the nucleus. This is not coming from outside losing electrons. We had a chromium with a +1 charge. And if you can imagine a neutron having a positive charge and a negative charge, so a positron and electron. So it loses that, and so what happens is then the mass doesn't change, so it's still 54, but what happens is this increases in number by 1. Because what happens is a neutron, by losing an electron, becomes a positron, or becomes a proton. And so again, you look at your periodic table, and then now you have manganese. Okay, so alpha particle is a helium nucleus. The beta decay is, again, an electron. Well, the third type then is a positron emission. And again, this is called alpha decay. And this is also decay. In a positron emission, essentially you'll sometimes see it referred to as, again, beta with a plus charge, resistance times negative, or typically you'll see it as 0 and +1. So in this situation, again, let's go to our chromium. And let's say that it goes through an electron capture. Excuse me, positron emission. I jumped the gun there a little bit. Okay, so it goes through a positron emission. So now we have a positron that's being emitted. So again, think about a neutron is a proton and an electron. So it's going through a positron emission. So the mass does not change. So it's still 54. But now a proton has given up that positron, makes it now a neutron. So it goes down in number. So it becomes 23. Then using your table, you get vanadium, or vanadium, excuse me. Okay, so we have alpha decay, beta decay, and positron emission as being 3 types. Now I'm going to switch over to the other side here, so I'm trying to get this all in. The 4th type is called electron capture. And in this situation, we have an element that is going to gain an electron. So in this situation, let's again go by chromium, and it's 54, 24. But now it's going to gain the electron. And in gaining that electron then, again, it's not gaining it in the outside, it's gaining the nucleus. So imagine a proton gains an electron, now it becomes a neutron. So again, we see this going down in number. So CR is, I'm sorry, we now have 23 and 54. And so again, you see that forming vanadium there as our example. And sorry, let me slide this over just air so you can see a little better. Sorry about that. And then the fifth type is gamma decay. And typically gamma is written like this, and gamma is pure energy. And gamma decay can occur with any of these other type of decay. Alpha decay, if you were to have an alpha gun, I could hold up a piece of paper and that would stop an alpha particle. Alpha particle hitting your skin would do a lot of damage on your skin, but your skin would stop it, so it wouldn't penetrate and hurt you inside. Beta, on the other hand, can penetrate, and it can penetrate a block of wood. But I could put a thicker piece of wood up there or some concrete, and that's going to stop beta because it's got some mass to it. But gamma, no. And we're talking thick lead, concrete, everything else to try to stop gamma radiation. So gamma radiation can do the most damage to living organisms. But anyhow, these are your 5 types of decay. I know you had that on other videos, but I want to at least go over it once again before I get into the next thing, was looking at decay series. So I'll stop this video and we'll do the decay series next.